dive in. All right, so we started Unit 2, which is just kind of a short little unit on population, sample, sampling completion. What notation describes different parameters and statistics for a population or a sample? Different sampling methods, experiments, studies, and going to be standard 8 we're going to come to later. This is a pretty short unit. I don't think there's a whole lot to it. It's not really math. It's not very computation heavy. It just talks about some of the different concepts behind population sampling. So yesterday we got into notes up on the board. Population sample. Population is all of it. A sample is some. I can't ask everyone in the population, so I take a sample, and hopefully the data I collect from that sample of the statistics are an accurate reflection of the parameter I'm trying to estimate. Sometimes there are bias. Different types of bias are on the board. Sometimes if your survey is not anonymous, responses might be inaccurate. You're probably not going to tell the truth as much to a police officer as a friend. Voluntary response bias. You have a poll where answers are given voluntarily. People who respond to the poll probably have a pretty strong opinion one way or the other. So you're not getting quite all the information. The data is being skewed. Selection bias. Selection bias occurs where not every part of the population has an equal chance of having been sampled. If I want to know something about the school and I stand out in front of the secondary building and ask people on their way in, what about the people who come in another door? Can they be a part of my sample? No, because they don't get a chance to respond. I'm only getting probably all the high school and junior high students and none of the elementary students that come in through a different door. My data is skewed. Not everyone has an equally likely chance of having been selected. We've also got several different sampling methods to collect a sample in the second column. We went through a little bit of those in class yesterday, but I think a better way to get a deeper understanding of what each of these sampling methods means and how it is applied is to actually kind of see it in action. So that's what we're going to do. I'm going to run through each of those 5 different sampling methods for you guys here in class today. What I want to know is what part of the population, what percent of the population has brown eyes? That is my parameter of interest. I'm trying to estimate that parameter by taking a sample. Hopefully the data that I collect is an accurate reflection of the parameter I'm trying to get. I can't ask everyone. A census is too time-consuming and expensive, and generally by the time I ask everyone, the population has changed anyway. So that's why we use sample. So, think about your eye color. It's a simple yes or no question. Do you have brown eyes? Because chances are I'm going to ask you that as I run through each of these different sampling methods, okay? All right, so simple random. A simple random sampling method is where I select people randomly. Everyone has an equal chance of having been a part of my sample, of having been selected. So I dropped everyone's names into a randomizer online. There it is. So there's about 12 or 13 of us in here. Let's break it into 2 groups. You have an equally likely chance of having been placed into the 2 groups. If you're in the first group, I'm going to sample you. This is a simple random sample. Everyone has an equally likely chance of being in the group that I'm going to pull. All right, so Chris, do you have brown eyes? Yeah. Who else do I got here? Nora, yes or no? Jaden, brown eyes? Isaac? Maya, yes or no? Brown eyes? And then Alan? No. So I pulled 1, 2, 3, 4, 5, 6. My key hat. So I'm trying to estimate the population parameter. Overall, the entire population, P represents what part of the population has brown eyes. P hat is my sample proportion. In my sample, what part had brown eyes? These are 2 different numbers, usually. That's why they get 2 different notations. One refers to the population, one refers to the sample. So in my sample, using simple random sampling method, I had 1 out of, 6?
Sure.
And that would be, oh, there it is. Forget 1 6. I think it's like 167. Yeah. So about 16.7% of my sample had brown eyes. Stratify. This is where I break into groups and randomly select. I think there's a lurking variable. Different groups might have different proportions of brown eyes in them, so I'm going to sample equally from different groups and record the results. So the groups that I had in mind are male and female. I separated you guys out into 2 other randomizers, and I'm going to get equal parts of male and female for this sample. Break into groups and sample randomly from therein. That would be stratified. Groups, and then randomly select. So let's see, I've got 2 groups here. I'm going to take the first 3, Chris, Connor, and Ethan. So Chris, you brown eyes?
Yeah.
Connor, how about you?
No.
And Ethan?
No.
Okay. Now I want 3 girls to match the first 3 gentlemen. So I've got 4 girls in this list. Let's just take the first 3 that pop up when I put them into 2 different groups. So Claire, Maya, and Nora, you're a part of this sample now. Claire, yes or no? Brown eyes? No, got it. And next up would be mine. Brown eyes? No. And then who else was next? Nora, yes or no? So P hat was the same 1/6, which is 0.167. That's just kind of happenstance. Could those numbers have been different? Yeah. What is that called? That phenomenon has a specific name, where different samples produce different results. What's that phenomenon called? 2 words, 2-word phrase I'm looking for. First one starts with sampling. Second one starts with a V. I. That's B, 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 B. Sampling, what, Nora?
Right.
Close, sampling variability. Sampling variability is just the natural tendency to get different results in different samples. Why would those different results might produce different samples? Different ways of sampling. I'm going to pull different people, right? I just kind of coincidentally got the same results, but didn't I ask different people here than I did here? So could I have gotten different numbers? That's just normal variability. Something we really can't control. It's kind of out of our realm of control. We have to deal with. I might get different results in different samples. That's not a problem. That's just going to naturally happen. What I want to avoid is any bias in my samples. This is designer error. You can do better if you select a more appropriate sampling method and get rid of bias. Sampling variability, that's just going to. Okay, let's do cluster. Cluster sample is very similar to stratified in that I'm going to break you up into groups, but now I think the groups might look the same. So I'm going to ask everyone in a single group. In stratified, I think the groups look different, so I want to get an equal amount of the different groups. In a cluster sample, I think the groups look similar, so it doesn't matter which group I select and ask all of them. I take a census of one whole group. So let me go back and ask all of the men. Let's just go right across. Chris, yes or no?
No.
Well, the end of this is probably
no, wait, yes.
Connor, yes or no?
Chris is no. I do. I am a yes.
Okay, I was gonna say.
No.
No, okay, cool. So now I've got Ethan. Now I'm gonna ask it.
Yes.
Awesome.
Yeah, get in here.
Now I'm gonna ask Jack.
No.
And then Isaac.
No.
And Alan.
No.
So 1, 2, 3, 4, 5, 6, 7.
Alan, you sure?
My sample proportion based off of cluster sampling is 2/7.
They're blue. They're literally blue.
So using this sampling method, my sample proportion is 28.6%. There we go. Now I have some sampling variability. In the process of doing different sampling method, I ask different people. So I'm going to produce different results more often. This is normal sampling variability. Any differences in sampling that might produce different results. Does that make more sense now?
Yes.
Stratified and clustered. Here I think groups look different, so I want to get an equal representation across the different groups. Cluster sampling, the groups I think look similar, so it doesn't matter which group I ask.
Whenever you're ready.
Go ahead.
What is it? Yeah, we say red and those brown eyes. What is mine?
I guess I go to Amazon. I'm just gonna go to
Casey's.
Emails. 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 I was gonna have more people with brown eyes. Brown eyes I've read was like the most popular eye color. Most prevalent eye color. Maybe I was wrong. Brown or blue are probably the two most common, don't you think? Green is probably less common. Hazel or gray, the same.
We have a lot of
A lot of blue-eyed people in the school. I forget which one's the dominant. Blue is dominant.
Yeah.
Is it? Oh, brown's.
No.
Dominant trait, recessive trait.
All three.
All right, I gotta have everyone back before I can move on. Everyone back? Awesome. I need people in here so I can make a sample. All right, we've run through simple randomly selecting. We've run through breaking it into groups with stratified or cluster sampling. The next up is systematic. This is where I have a system, a rule, a procedure to select people to be part of the sample. It's not truly random because I am applying a process. In simple random, you're just pulling things out of a hat almost. Just drawing random. In systematic, I'm going to ask every nth object or nth thing or nth person. So I'm going to ask the second, the third, the fourth person. In this case, let's ask every other person. Every second person, I'm going to have a part of my sample. So Jaden, I've got this list here. Yes or no? Sorry, guys, I'm just going to have to keep asking you the same question here, but it is what it is. Gabe, yes or no?
Yes.
Moving down, I had Nora, brown eyes, yes or no? By the end of this, I should know. Jack P, what were you again?
No.
I'm systematically going through and asking every other person. And then Chris.
Yes.
Yes. So in this case, I have 1, 2, 3, 4, 5. My sample proportion as a means of estimating my overall population parameter P. P hat, my sample proportion was 2 out of 5, which is 40%. First hour, I actually had one where I had none. It's kind of weird, 0%.
Jack, you going back?
All right, let's do a multi-stage. Multi-stage is a combination of more than two or more different sampling methods. So first up, I'm going to group it. Let's group it into male, female. And then ask every other person. It's similar to stratified, where I broke into gender, male, female, but instead of just picking random people within those two groups, male, female, now I have a system where I ask every other person to be part of the sample, brown eyes or not. I'm applying stratified sampling with systematic sampling. Okay, so let's do the guys first. Every other person, we're going to start with Ethan. No. Now I've got Jack.
No.
And then I've got Chris.
Yeah.
Oh yeah, I totally it down.
We carry.
And then I'm going to ask every other female. So let's start with the top. Maya. Yes or no? Yes?
No.
No. Okay, I'm sorry. And then I'm going to ask Claire. Yes or no? Claire, it was a no, wasn't it? So in multi-stage, where I stratified the groups, I broke into different groups, into male, female, and then systematically asked every other person. This is a multi-stage sample. So no, no, yes, no, no. That would be 1 out of 5. Or 20%. Different sampling produces different results. That's normal sampling variability. That's unavoidable. As statisticians, we just have to live with it. Our sample might differ from the parameter because of bias, which is something I want to try to eliminate. That would be designer error. Different response bias to skew my results. Do those kind of make more sense now? Now that you've seen them in action? Okay. Let's go ahead and get our laptops out. Next thing I have for you, I'm going to send you in your email. Now that we've seen a little bit more on sampling methods, I have some questions where you're asked to read a scenario and describe what sampling method was applied.
Roger, pizza or pizza? Pizza.
All right, so I think I just sent you guys this form called sampling methods. Take about 5-10 minutes. I'll let you work through this. Whatever time we have left over, I'll get you started on practice problems. We'll come back tomorrow. We'll give you some more time to work on practice problems. Monday, we're going to review, and I think I have a quiz planned on Tuesday. This one goes pretty fast. We'll quiz again on Tuesday like we did this week over standards 5, normal distributions, and then 6, 7, sampling methods, population sample questions. So on this form, everyone got this? First section, read through each situation, describe if it describes a simple random sampling method, a stratified sampling method, a cluster sampling method, or something else. None of the above. On section 2, this is where I ask you to identify different population parameter and sampling statistic notations. On your quiz on Tuesday, I'll probably give you some notation for you to describe. I'll give you a description where you give the notation. So practice that on section 2. You've got mu to identify on question 1, and so on. That make sense?